The locus of points between two solid lines that are parallel is another set of points that's equal distance from the top line and from the bottom line, and that also is parallel to these two originals. So the set of points between two lines is a single line. If you start out from the perspective of just a single line, there are two sets of loci on either side of it. Both are parallel to the original. So these are equal distance from the original line. So one line has two sets of loci, and as we saw in the example before, two parallel lines, two lines, have one set of loci in between it. Speaking of parallel lines, here are two parallel lines cut with a transversal. Transversal is another line that actually intersects both of the parallel lines. And of course, they form angles. There's this area right in here between the two parallel lines is known as the interior. And so the angles that are here, this one, this one, this one, and this one, those are interior angles. The angles that are outside of the two parallel lines are called exterior. And those angles, this one and this one, this one and this one, are known as exterior angles. So when you're looking at this very busy drawing, you're going to be focusing on the two parallel lines cut or intersected by this transversal. The angles that are in the interior that are next to each other, that would be a blue and a red, add up to 180 degrees. That's because they're on a straight line. And a straight line, as you recall from the vocabulary, look back in your notes, you have it. A straight line measures 180 degrees. So the blue angle plus the red angle, the blue angle plus the red angle has to be equal to 180 degrees. So if we knew that the blue angle was, let's say, 100 degrees, then the red angle would have to be 80 degrees. So you can figure that out. These are supplementary angles, and we have two sets of interior supplementary angles. Now, if you focus on the exterior angles, again, we have a blue and a red. These add up to 180 degrees. So all of our exterior angles and our interior angles, the side-by-side angles, measure 180 degrees. Another interesting thing that happens is when you have the angles that are right across from each other, so here we have an interior with an exterior, both of the blue angles are the same, and both of the red angles are the same. Same here. And also, if you knew this angle right here, if we pick this up and set it down here, the red would match up with the red. The blue would match up with the blue. This red angle would cover this one, and this would cover that. If you knew the dimensions of one single angle in this setup, you could figure out all of them. Let's say that our blue angle is equal to 120 degrees. So we would have two lines cut with a transversal. So if this is 120 degrees, we know that the opposite angle, the angle that's right across from it, is also 120. And if we would lift this up and put it on top of that, we would have 120 here and 120 here. So we've already figured out all of the blue angles in this setup. If we take our 180 and subtract off the 120, we would realize that our red angle had to equal 60 degrees, because 120 plus 60 is 180, and that is the measure of the straight line. So coming back to our drawing here, we would know that these were all 60 degrees. We only knew one piece of information, and we could figure out the rest. You'll use this information a lot because there are many, many test questions and homework questions that have to do with parallel lines cut with a transversal.